Theorem 10.3. The perpendicular from the center of a circle to a chord bisect the chord. The perpendicular from the center of a circle to a chord bisect the chord. This means that if a perpendicular is drawn from the center to a chord, then the chord divides as two equal parts. That means if OP is perpendicular to AB, then AP is equal to PB. You have to by heart the statement, the perpendicular from the center to a chord bisect the chord. Next theorem, the line drawn through the center of a circle to bisect the chord is perpendicular to the chord. The just converse of the previous one. If a line is drawn through the center of a circle to a chord and it bisect, that means AP is equal to PB, then we can say that OP is perpendicular to AB. That means if AP is equal to PB, a line is drawn from center to a chord in such a way that AP is equal to PB, then what we can say is OP is perpendicular to AB. The first theorem was the perpendicular from center to a chord bisect the chord. Here the converse of that, if a line is drawn from the perpendicular to a chord in such a way that it bisects, then we can say that it is a perpendicular. Next, circles to 3 points. First we have to consider one point. See, one point here. We can draw infinitely many circles through a given point. Then what about 2 points? Here 2 points. Here also we can draw infinitely many circles through 2 given points. Next one is a circle. How many circles can be passed through this 3 points A, B and C? The theorem says there is one and only one circle passing through 3 given non-collinear points. If we have given 3 non-collinear points, we can draw only one circle, one and only one circle passing through 3 given non-collinear points. See, if we have 3 non-collinear points like this, we can draw a triangle like this. So, I have drawn a triangle ABC joining all the 3 points, and this circles which lies outside this triangle is known as circumcircle. It is known as circumcircle, and the center is known as circumcenter, and the radius is known as circumradius. So, circle is known as circumcircle, center is known as circumcenter, and the radius is known as circumradius. Then exercise 10.3, first question. Draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? See, first case, how many common points? No common points here. No common points. First case. Second case, one common point. Then the third case, how many common points? 2 common points. So, this is the maximum. Why? We can draw only one circle passing through 3 given non-collinear points. Here 2 points. So, how many maximum number of common points? 2 is the maximum number of common points. Then exercise 10.3, third question. If 2 circles intersect at 2 points, prove that their centers lie on the bisector of the common chord. what you have to prove is, if two circles intersect at 2 points, two circles intersect at 2 points A and B. Two circles intersect at 2 points A and B. We have to prove that their centers lie on the perpendicular bisector of the common chord. Their centers lie on the perpendicular bisector of the common chord. This is the common chord. This is the line segment which lying on the which joins both the centers. So what you have to prove is O dash is the perpendicular bisector of AB. We have to prove that O dash is the perpendicular bisector of AB. So we have to consider two circles with centers O and O dash, and AB is the common chord. We have to prove that O dash is the perpendicular bisector of AB. So first we have to consider two triangles, triangle AO dash and triangle BO dash. Prove the congruence in these two. Prove triangle AO dash and triangle BO dash are congruent. Consider triangle AO dash and triangle BO dash. You have to prove the congruence. What about OA and OB? OA is equal to OB because radii of the same circle. OA is equal to OB radii. Then same way O dash A. O dash A is equal to O dash B. O dash A is equal to O dash B radii. Then last one, O dash is common in these two. So O dash is equal to O dash common. So what we can say, triangle AO dash is congruent to triangle BO dash. So if these two are congruent, we can say these two angles are equal and these two angles are equal using CPCT. So angle AO dash is equal to angle BO dash, and angle AO dash O is equal to angle BO dash O using CPCT. What do you have to prove? We have to prove AB O dash is the perpendicular bisector of AB. That means we have to prove AM is equal to BM and this makes 90 degree. That is what we are going to prove. So first we have taken two triangles AO dash and BO dash, and we have proved that these two are congruent. So by using CPCT we can say these two angles are equal and these two angles are equal. Next I am going to consider these two triangles OAM and OBM. Consider triangle OAM and triangle OBM. Triangle OAM and triangle OBM. Can you prove the congruence in these two? Yes. OA is equal to OB. OA is equal to OB because of radii. Then OM is equal to OM common. OM is equal to OM common. What's the next one which we can use? We can use this. Angle AOM. Angle AOM is equal to angle BOM using the CPCT equation 1. Using 1. So what we can say, triangle AOM is congruent to triangle BOM using SAS criterion. Triangle OAM is congruent to triangle OBM using SAS criterion. If these two are congruent, what we can say? AM is equal to BM and these two angles are equal. But what about the sum of these two 180 degree using linear pair, because the sum is 180 because they form a straight line. So what we can say? And AM is equal to BM using CPCT, equation 2, and angle AMO is equal to angle BMO using CPCT. But what about the sum of these two? 180 degree because it makes a line. But angle AMO is equal to, not equal, plus angle BMO is equal to 180 degree because it is a straight line. AMB is a straight line. So it makes 180 degree. So this you can write as third equation. This you can write as fourth equation. Both the angles are equal and sum is 180 means each is equal to 90 degree. This implies that angle AMO is equal to angle BMO is equal to 90 degree using 2 and 3. Using 2 and 3. So what you can conclude? So what we got is AM is equal to BM and each of this equal to 90 degree. That means that OO dash is a perpendicular bisector of AB.